So reach question 5, which is module 3. Module 3. Module 3 constitutes of differentiation, integration, limits, and continuity. So looking at module 3, this question says use the substitution u as this to integrate this right here. So using that substitution, we're substituting u as x to the 4 plus 2, that is u. So if that is u, then you need to find du. Then du is going to be equal to carry down the power, which is 4x cubed dx. So of course, I'm going to call this integral I. I love to call them I. And so I is equal to, now look what I'm going to do. I'm going to write I as the integral of, instead of saying 4x to the 7, I'm going to break up 4x to the 7 as 4x cubed times x to the 4. Yeah, man. So I'm going to rewrite it as x to the 4 plus 2 all cube. And then, as I said, instead of writing 4x to the 7, I'm going to write it as times x to the 4, putting x to the 4 first, times 4x cubed dx. I might say, sir, why put it in that order? I put it in this order so I can use my substitution. X to the 4 times 4x cubed is still going to give me 4x to the 7. All right. Now, once you get to this stage, you're good, because guess what? You see right here, 4x cubed times x to the 4. These two right here, look at that. 4 plus 3 is 7. So this is still 4x to the 7. But this part right here, this 4x cubed dx, this part is du. This part is u cubed. X to the 4 now. Now if x to the 4 plus 2 is u, then x to the 4 by itself is just u minus 2. That implies that u minus 2 equal x to the 4. Yeah, man. So no good now, let us substitute. You'll see it better when we substitute. So I is working out clearly to be the integral of x to the 4 plus 2 cube, which is going to be u cube times x to the 4. X to the 4 is u minus 2. U minus 2. And then 4x cubed dx is du. That is du. Nice and easy, soft. So we can go ahead and finish this. We're going to have u to the u cubed times u is u to the 4. Then u cubed times 2 is minus 2u cubed du. So all I know is add 1 to the power to get u to the 5th. Divide by the power of 5. Minus, add 1 to the power to get 2u to the 4. Divide by the power of 4. Plus some constant c. Nice and easy, soft. So now that we have that now, we can resubstitute back for u. So resubstitute back what was u? U was, what is u again? U is x to the 4 plus 2. All of this just work out to be x to the 4 plus 2 raised to the 5th power And instead of saying divide by 5, I'm going to put 1 over 5 on the outside. So it's 1/5 of this minus 2 over 4 is really a half. So it's minus a half times u to the 4 is just x to the 4 plus 2 raised to the 4th power. X to the 4 plus 2 raised to the 4th power plus some constant c. Nice and easy, soft. That is this question. Nice. All right, now this question says calculate the area of the region lying between the parabolas y equal x squared and x equal 1 over 8y squared. To calculate the area between these two, we are going to have to find the point of intersection. And first thing is, if I cross multiply, this equation is really saying 8x is equal to y squared. All right, so cross multiply 8x is equal to y squared. Now y is equal to x squared. So if y is x squared, then I can substitute for y as x squared. So what that is telling me then is 8x is equal to, substitute for y squared as x squared, so I get x squared squared is x to the 4. So 8x equal x to the 4. I carry that over to get x to the 4 minus 8x. And that's equal to 0. And so one possible answer will be x equals 0. That's one answer, comma. Now the next answer I'm going to get is x cubed minus 8 is equal to 0. Now this is clear what x is. X equal 2. 2 cubed minus 8 is 0, so x equal 2. Clearly x must be 2. So the point of intersection are x equals 0 and x equal 2. You don't need to find the y point of intersection. You don't need to. Because when we're integrating to find area, the integral A, area, is going to be equal to the integral from x1 to x2, or you can say from A to B, of the first curve, y1, minus the next curve, y2. So you're going to put the two curves in together, dx. All right, that's all. Now, let's go ahead and do that. But first thing, we need to make y the subject of both of them. Now, in this one, y squared is 8x. So you can clearly see that then y would be equal to the square root of 8x. So in this case, the area is going to be equal to the integral from 0 to x being 2 of y1, we can call y1 x squared, minus y2, we can call y2 8x to the half power. This is 8x raised to the half power. All right, dx. So let's go ahead and do this integration. Doing this integration, we add 1 to the power to get x cubed divided by the power of 3 minus, we add 1 to the power to get 8x half plus 1. A half plus 1 is 3 over 2. Then we're going to divide it by 3 over 2. And also divide it by the differential in the bracket, which is 8. So divide it by 8 times 3 over 2. And we have to bear in mind that we're integrating from 0 to 2. Now in reality, we don't ever need to plug in 0 in these sort of circumstance. You just need to plug in the 2 rather. So when you plug in 2, you're going to get 2 cubed over 3, which is 8 over 3, minus, when you plug in 2 here, 8 times 2 is 16. So we have 16 times 16 raised to the 3 over 2, which is 64, divided by 8 times 3 over 2, and I'm getting 16 over 3. And so 8 over 3 minus 16 over 3 is minus 8 over 3. But as you know, area is positive, and so the area is just 8 over 3. All right, and so the area is 8 over 3. Even though I get minus here, the area is positive. So the area is 8 over 3 units squared. Now the only reason why I get minus, this just means that I integrate, it should have been the other way around. I integrated the one that is below as above and the one that is above as below. That's all that means. So it is positive 8 over 3 units squared. That's the area. All right, so finish up integration, and now we reach differentiation. It says the equation of a curve, it's a quartic expression. F of x is 3x to the 4 minus 2x cubed minus 6x squared plus 6x. Find f prime of x. Now f prime of x, this means that we're finding the first derivative. We carry down the power to get 12x cubed. Carry down the power, 12x cubed minus, carry down the power, we get 6x squared. Carry down this power again, we get minus 12x. And then differentiate 6x, we get plus 6. So that's the first derivative. Right here it says determine the second derivative. The second derivative is f double prime of x. F double prime of x is going to be equal to, when we differentiate 12x cubed, you're going to get 36x squared. Then you differentiate minus 6x squared, you get minus 12x. Then you differentiate minus 12x, you get minus 12. Nice. All right, let's see. 36x squared minus 12x minus 12. Good. So we find the first and second derivative. Nice. It says calculate the x coordinates of the stationary points. So you have to remember stationary points occur when f prime of x, or some people would say dy by dx equals 0. So it occurs when f prime, please look at this, see that it is f prime of x. F prime of x we found is 12x cubed minus 6x squared. Let's write it down. So we're going to be solving 12x cubed minus 6x squared, 12x cubed minus 6x squared minus 12x, 12x cubed minus 6x squared minus 12x plus 6. And we're solving that equals 0. So what we do is divide through by 6. And dividing through by 6, we're getting 2x cubed getting 2x cubed, minus divide through by 6, we're getting x squared. Dividing through by 2, we get minus 2x. Dividing through again, we get plus 1. And this is equal to 0. If you're wondering what I did, all I did was divide through the expression by 6. So we're going to solve this cubic equation. To solve this cubic equation, we can use trial and error to find the root. So we're going to use trial and error. So we're going to try x equal to, let's say 1. 2 minus 1 minus 2 plus 1 is 0. So 1 works. So try x equal to 1. Trying x equal to 1, it works. And so 1 is a root. So 1 is a root. Now, if 1 is a root, then you could want to use factor and remainder theorem to solve it. But I'm tired of using factor and remainder theorem, so I'm going to use sums and products of roots. Now, the sum of the root from this equation, the sum is minus b over a. So minus b is a half. This works out to be a half. The sum of the roots is minus b over a, and the three roots are 1, and then the next two roots, I'm going to call them a and b. So 1 is equal to a plus b. All right. And then the product of the three roots is going to be minus d over a, which is minus a half. And minus a half is equal to 1 times a times b, which is ab. Good. So what I'm getting then is from this equation right here, all right, from this equation, these two equations, I'm going to solve them simultaneously. Solving them simultaneously, what I'm going to get is from the first equation, I'm going to carry over the 1, and so I'm getting a plus b is equal to a half minus 1 is minus a half. Then I'm going to multiply through by 2. Multiply through by 2, I get 2a. Yeah, 2a plus 2b is equal to minus 1. That's what I'm getting from the first equation. And from the second equation, I can divide through by a. So I'm getting that b is equal to, if I divide through by a, I get minus 1 over 2a. So these are the two equations I have now. I have 2a plus 2b equal to minus 1. I have b is equal to minus 1 over 2a. So I'm going to plug this equation in this equation. So doing that now, I'm going to get 2a plus 2b. 2b will now become minus 2 over 2a. And that's equal to negative 1. And so I multiply through by 2a. And so this will become 4a squared. 4a squared. Minus 1 times 2a. When I bring it over, it will become plus 2a. If you're wondering where I get the plus 2a from, the minus 1 times 2a is minus 2a. And I bring it over to this side. Minus 2 is equal to 0. I can then divide through by 2 to get, let me just finish it off right here. If I divide through by 2, I get that 2a squared plus 2a squared plus a minus 1 is equal to 0. Now I can factorize. Or if you can't bother factorize, just use quadratic formula. So a is equal to minus b, which is minus 1, plus or minus the square root of b squared minus 4ac over 2a. So it's 1 squared. So it's 1 squared minus 2 times minus 1. So it's minus 1 plus or minus the square root of 5 over 2 times 2, which is 4. That's what I get for A. All right, so now if A is these two values, you find the two roots. All right, you find the two roots and then you find them. So one of the root is going to be minus 1 plus root 5 over 4. And the other one is going to be minus 1 minus root 5 over 4. And one root is 1. So good. All right, so we can write it down that hence the x coordinates of the stationary points are, imagine they're giving away 11 marks for this. So easy. So find it there, x equal 1, comma, then you have x equal to minus 1 minus root 5 over 4, comma, and then you have, what's the next one? Minus 1 plus root 5 over 4. So these are the three x coordinates of the stationary point. Now they didn't ask us to find y, they only said x coordinates. All right, so now they said determine the nature of these stationary points. To determine their nature, you have to go back to the second derivative, which is this 36x squared minus 12x minus 12. So I'm just going to write down the second derivative up here again. So just to refresh our memory, f double prime of x is equal to 36x squared minus, it was minus 12x, I believe, minus 12x minus 12. This is 36x squared minus 12x minus 12. That's this, all right? That's the second derivative. So all we need to do now is find f double prime of 1. When we find f double prime of 1, what we're going to get is f double prime of 1, we have 36 times 1 squared minus 12 times 1 minus 12. So f double prime of 1 is 12, which is greater than 0. And so we can conclude x equal 1 is a minimum point. X equal 1 is a minimum point. So this is a minimum point since the second derivative is greater than 0. Now do the same for here. So when x equal to minus 1 minus root 5 over 4, so f double prime of minus 1 minus root 5 over 4, find f double prime of this, and you're going to get that this is equal to, put it in the formula up here, minus root 1 minus root 5 divided by 4, and I have 36 times that square minus 12 times that minus 12. I get 21.2. I get 21.2. Which is greater than 0. Since it's greater than 0, this is also a minimum point. So I can write, so up here, x equal that is a minimum point. And finally, going down here now, we have f double prime of minus 1 plus root 5 over 4. minus 1 plus root 5 over 4. Working out this, what we get is minus 1 plus root 5 divided by 4 is 0.3. 36 times that square minus 12 times that minus 12, that's negative 12. So in this case, we get negative 12, which is less than 0. And so this is a maximum point. So you can tell them that x equal minus 1 plus root 5 over 4 is a maximum point. Nice and easy, soft. The capital T. Nice. So this is a maximum point. Nice. Okay, that takes care of question 5. And now we move on to question 6, the final question on the paper. So looking at question 6, it says a function f is defined as f of x is x to the 4 minus 1 over x, and 4x and 2. Determine whether or not the limit of f exists when x is equal to 1. So we just need to show that the left-hand limit equals the right-hand limit. So first I'm going to work out the left-hand limit. So the limit as x approaches 1 from its left of f of x, it's going to be equal to, this means when x is less than 1, so you use the top function. So that's going to be equal to the limit as x approaches 1 of x to the 4 minus 1 over x minus 1. So when we're doing this now, what this works out to be, it is equal to the limit as x approaches 1 of x to the 4 minus 1 over x minus 1. X to the 4 minus 1 can be broken up as x minus 1 times x cubed plus x squared plus x plus 1. And so now we have all of this is being divided by x minus 1. And so if all of this is divided by x minus 1, then x minus 1 cancels each other. Then you plug in 1 now and you get 1 cubed plus 1 squared plus 1, 1 cubed plus 1 squared plus 1 plus 1. And you add those 1 and you get 4. So that's the left-hand limit. So now let's check the limit on the right-hand side. So we need to evaluate the limit as x approaches 1 from the right. So checking the limit as x approaches 1 from the right, what we're going to be getting is, so plugging in on the right, it's the limit as x approaches 1 of 4 times x. So all you need to do is plug in x as 1 now. And so what you're going to get is 4. Now since the left-hand limit and the right-hand limit are equal, then the limit exists. So since the left-hand limit and the right-hand limit are equal, then the limit does indeed exists at x equal 1. So yes, the limit does exist. It says determine whether f is continuous as x equal 1. We can put a big dirty no. No, it is not continuous. And the reason is f of 1 is equal to 2, but the limit of f of x is equal to 4 as x approaches 1. And so the limit is not equal to its functional value. At x equal 1. So it's no. The limit is 4, but f of 1 is 2. So it is not continuous. Next part. It says the parametric equation of a curve is given by x equal 2 cos theta and y equal 3 minus sine theta. Determine the derivative of g of x. So there's two ways you can tackle this. There's two ways. First you could do is find g of x, right? Can I do it method? Yes, let's do it the two ways. So I'm going to put a line right here, doing it two ways. Method 1 and method 2. Method 1. Method 1 is, what you could first do is you could say, well, x is cos 2 cos theta and y is 3 minus sine theta. So if you make sine theta and cos theta the subject from method 1, you would get that x over 2 is cos theta. X over 2 is cos theta, and you would be getting that sine theta is equal to, bring over sine theta, bring over y, 3 minus y. So 3 minus y is equal to sine theta. But remember, sine square plus cos square equal 1. So that implies that 3 minus y all square sine square plus cos square. Cos square would be x square over 4, and this is equal to 1. All we need to do is make y the subject here. By making y the subject, you can first expand this to get 9. All right, I don't need to do that. First thing you can do is to make y the subject, bring over this to get 3 minus y all square. So 3 minus y all square is equal to 1 minus x square over 4. You can then square root both sides. So I'm going to then square root both sides. When I square root both sides, this is what I get. And then I can, after I square root both sides, the square cancels the square root. And so then what I'm left back with is 3 minus y equal this. And so that means that y is equal to 3 minus the square root of, and instead of saying square root, I'm going to say y is equal to 3 minus 1 minus x squared over 4. Y is equal to all of this raised to the half power. Why did I put it to the half power? All you need to do now, this is now g of x. So this y is now g of x. So now you could find g prime of x. That's method 1. We're going to come back to this method. I'm just going to show you how we're going to get the same thing. And I'm going to put it in terms of theta because we know x as 2 cos theta. So we're going to come back to this. I'm just going to do it the parametric way now. The parametric way is to say that this is really, g of x is really y. So really what they're asking you to find is dy by dx. This is now method 2, which most people will do. Dy by dx is equal to dy by d theta, dy by d theta divided by dx d theta. This is dy by dx. And so what you're going to get is dy by d theta. Differentiate this with respect to theta. When you differentiate sine, you get cos. That's going to be minus cos theta divided by dx d theta. When you differentiate 2 cos theta, you get minus 2 sine theta. And cos over sine is cot, and the minus is cancelled, and so you get a half cot theta. So this is the answer, half cot theta. This is method 2. But what I want to show you is from right here, we're going to get the same answer. We're going to get the same answer. This is method 2. What I want you to do now, can I make a little bit more space? Differentiating this, you carry down the power to get a half. You subtract 1 from the power. So you're going to get 1 minus x squared over 4. And you subtract 1 from the power to get, minus a half minus 1 is minus a half times the derivative inside the bracket, and the derivative inside the bracket is times 2x, or rather times minus 2x over 4. That's g prime of x. And you might say, so how are you going to get it to look like this? Don't worry, that's the least. So I'm going to finish it off right here. I'm going to carry method 1 up here, the draw arrow. Just going to finish off method 1 in this small space. Now this the minus, the 2 here cancels the 2 here. And so what you get is 1 over 4 minus 1 over 4x. So we get now that g prime is equal to minus 1 over 4 x times 1 minus x squared over 4, and all of this is being raised to the minus half. This is what you're getting for g prime. But remember, x is what? 2 cos theta. So x is 2 cos theta. So 2 cos theta over 4 is going to be minus cos theta over 2. So you get minus cos theta over 2. And that is now being multiplied by, in this bracket here where you have x squared over 4, x squared over 4 is going to be cos squared theta, and 1 minus cos squared, this is now 1 minus cos squared. 1 minus cos squared is sine squared. So in here, so work out to be sine squared theta (1 minus x squared over 4 is sine squared theta, and it's sine squared theta to the minus half, and sine squared theta to the minus half, sine squared theta to the minus half. That is just sine theta in the denominator. So all of this will work out. So you can finish it off and see it. But why do I have a positive here? This will be minus a half. Let's see something. dy is minus cos theta minus cancel. So where did I forget the minus? Oh yes, there should have been a minus here. Minus a half. And the minus will cancel each other. So get rid of this minus now. The minus them will cancel each other there. Minus cancel each other there. And this will give you the same answer as a half cot theta. No more space. Of course, I would have showed it a little better because we know that sine squared theta to the minus half. This sine squared theta to the minus half, you can rewrite it into the denominator as 2 sine theta. Sine squared theta to the minus half going to come into the denominator as 2 sine theta here. Then cos theta over 2 sine theta is a half cot theta. So I'm saying you could have done it either way, method 1 or method 2, up to you. Method 2 is way shorter. It says determine the equation of the normal at this point. To find the equation of the normal, we use the point. We use y minus y value at the point, which is 5 over 3. And that's equal to gradient of the normal into x minus root 3. Before we can find gradient of the normal, we need to find gradient of the tangent. So we need to find gradient of the tangent first. So the gradient of the tangent is just going to be, now this is when x is root 3. This is when x is root 3. So the good thing is, you can find a gradient from this. Just plug in x as root 3 and get the gradient. Or if you want to use this formula, you need to find the value of theta that will give you x to be root 3. So from this here, x is 2 cos theta. X is 2 cos theta. So what's the value of theta to make x be root 3? All right, so x is 2 cos theta. Let's write it down around here. X is equal to 2 cos theta. So if x is equal to 2 cos theta, and in this case x is root 3, so we have root 3 is 2 cos theta. Root 3 is 2 cos theta, so we divide by 2, so that implies that theta must be equal to cos inverse of root 3 over 2, and all I did was divide both sides by 2 now. Divide both sides by 2, and that will give you cos theta is root 3 over 2. For cos theta to be root 3 over 2, theta must be, is that 60? Cos of 60? No, the cos of 30. So theta is pi by 6. So we're finding the gradient of the tangent when theta is pi by 6. So we're finding the gradient of the tangent when theta is pi by 6. Just want to let them know right there. So the gradient of the tangent is going to be, you plug in theta as pi by 6. In here, you're going to get, so the gradient of the tangent is the cos of pi by 6 divided by 2 times the sine of pi by 6. That will give you the gradient of the tangent. So the cos of pi by 6, cos of 30, cos of pi by 6, and we just found it. I don't know why I had to rewrite it, root 3 over 2. And that's being divided by the sine of pi by 6, which is the sine of 30 degrees is a half times 2 is 1. And so the gradient of the tangent is root 3 over 2. Now, since the gradient of the tangent is root 3 over 2, the gradient of the normal is now minus 2 over root 3. That's the gradient of the normal minus 2 over root 3. Now that we get the gradient of the normal, we're fine. We're absolutely good. So now we can say, okay, the equation of the normal, I'm going to write this now. This is the normal. So the equation of the normal is given by y minus the y value. What was the y value? The y value was 5 over 2. So it's y minus 5 over 2. That's equal to the gradient of the normal, which is minus 2 over root 3 into x minus root 3. Now, I am not going to go any further. I'm going to stop right here. You could proceed and simplify. Make y the subject. So this is the normal. I'm not going any further. Nice and easy, soft. All right, now this says now, the slope of a tangent of the curve at any point is equal to the product of the x-coordinate and the reciprocal of the y-coordinate of the point of tangency. Formulate an appropriate differential equation. So this is differential equation. So let's read this question carefully. The slope of a tangent of a curve G. So if it's a curve G, then the slope of the tangent is G prime of x. So the slope of the tangent at any point, they're telling us that G prime of x is equal to the product of the x-coordinate and the reciprocal, the product, it's a product, product of the x-coordinate, so the product of the x-coordinate and the reciprocal of the y-coordinate. The reciprocal of y-coordinate is, so it's x times 1 over y. So that's the differential equation. G prime of x is x times 1 over y. If G prime of x is equal to x times 1 over y, then I'm going to rewrite G prime of x now as dy by dx. G prime of x is the same as the first derivative, dy by dx, and that's equal to x over y. So if this is what we have, we can go ahead and solve this differential equation by cross multiplying to get y dy is equal to x dx. And then once you get to this stage, you integrate both sides. And when you integrate both sides, the integral of y is ln y. I'm tripping. Integral of y is not no ln y. The integral of 1 over y is ln y. I'm so used to getting an ln differential equation. The integral of y is y squared. That's equal to integral of x is x squared. And I forgot to divide by 2. Divide by 2 plus some constant c. I'm going to call it c1 for now because I'm not finished yet. Now I'm going to make y the subject by multiplying through by 2. Multiplying through by 2, I get y squared is equal to, multiply through by 2, I get x squared plus 2c1. And then I square root both sides now to get y is equal to the square root of x squared plus k. And you're going to ask me, sir, where that k come from? Where does k come from? K is just another constant where I let k, so you can tell them where k is equal to 2c1. K is equal to 2c1. That's all I did. Substitute a constant k for 2c1. Nice. Easy. Soft. It says, hence or otherwise determine the equation of the curve given that it passes through 1, 3. So pretty much they're asking you to find the value for k. If we pass through 1, 3, then they're telling us that when y is 3, x is 1. So 3 is equal to the square root of x squared, which is 1 squared, plus k. So you square both sides first to get 9 is equal to 1 plus k. And then you subtract 1 from both sides. So you get k equal 8. And if k is equal to 8, then that just tells you that y is equal to the square root of x squared plus 8. This is the final answer. Y is the square root of x squared plus 8. And this concludes 2018 paper. Very easy, very fun. Perhaps the easiest Unit 1 paper you'll get. I hope it was just as much fun for you as it was for me. And so stay tuned. See you next time.